Welcome to Preferred's April webinar, How Boiler Explosions Are Prevented. I'm David Oaf with Preferred Utilities, and I have been in the boiler industry as an engineer and a technician since 1990. So this presentation was adapted from a class we do periodically at Preferred for new employees. And one of the goals of the class is to enforce on the new employees that the work they do is critical to life safety. If they are careless in their work, someone can die. Boilers are inherently very dangerous devices. They introduce a combustible mixture of air and fuel in a confined space, along with high pressure steam and water hot enough to be steam but kept in a liquid phase by high pressure. They are very dangerous devices that need to be designed, commissioned, and operated correctly to remain safe. So ASME is the American Society of Mechanical Engineers. They kind of have their hand in everything, but they were originally founded in 1880 to determine codes and practices to prevent boiler explosions. Prior to the adoption of ASME codes, boiler explosions were common. There's four basic types of boiler explosions: a steam side explosion, dry boiler firing, a fuel side hard light off, and fuel side rich combustion. We're going to do a deep dive into each of these major types of boiler explosions. A steam side explosion is caused when the boiler steam pressure exceeds the design pressure of the boiler plus whatever safety factor is in the design. When the boiler pressure vessel ruptures, the steam escapes plus the water in the boiler flashes to steam, and you get that 1400 to 1 volume change from water to steam. This type of explosion is rare, and there are at least 5 devices on the boiler designed to prevent a steam side explosion. The first device to prevent a steam side explosion is the firing rate control. The firing rate control should drive the burner to low fire if the steam pressure exceeds set point. If the steam pressure continues to rise, the operating steam pressure switch should open and shut down the boiler. If the steam pressure continues to rise again, the high steam pressure switch should trip the boiler and energize the alarm. Finally, boilers are required to be provided with safety valves or pressure relief valves. Each of the 2 safety relief valves are sized to discharge more steam than the boiler is rated to produce. One valve is set about 5 psi higher than the other. These valves are very large when they are discharging. They will get everybody in the plant's attention. Steam side explosions are rare in fire tube boilers and virtually non-existent in water tube boilers because of their design. So design responsibilities for preventing boiler explosions or boiler steam side explosions are: the operating steam pressure and high steam pressure switches must be selected for the design pressure of the boiler. They need to be shown correctly on the wiring schematic. Usually the operating steam pressure switch will be in the recycle limits and the high steam pressure switch will be in the non-recycle limits. And no isolation valves are allowed between the boiler and the operating steam switch and the high pressure steam switch. So responsibilities for the boiler technician or boiler operator is to inspect the installation of the operating steam pressure switch and high steam pressure switches to ensure that they are piped and wired correctly. You need to test the operating pressure switch and the high steam pressure switches by carefully building up steam in the boiler to the required set points. An additional safety to prevent a steam side explosion is a safety relief valve, and most boilers are required to have 2. Safety relief valves need to be properly sized, set, and tested at the factory. They're required to have labels with their capacities and their set points on them. Technicians and operators need to inspect to make sure they match the boiler nameplate and are piped correctly. Safety relief valves are tested periodically using an evaporation test, where the boiler is driven to high fire and the safety is intentionally blown to make sure that each safety can relieve the full capacity of the boiler. When you run a boiler completely out of water, the steam pressure goes down, so the firing rate goes to high fire. The metal in the boiler is not protected by water anymore, so it gets hotter and hotter. Eventually, the overheated metal creeps and the boiler sags on its mounts, and the boiler is a total loss. Worse yet, an operator might notice there's no water in the boiler gauge class and restores water flow to the boiler. Maybe the feed water pump was tripped off. When the water hits the hot steel, it flashes to steam and ruptures the boiler pressure vessel. Personally, I've seen a boiler dry fired. I've never personally seen a boiler explode after running out of water, but it is one of the most common causes of boiler explosions. Most boilers have 4 safeties to prevent dry firing, and the first safety is the feed water control system. When the feed water control system is running properly, it keeps the boiler at its normal operating water level. The second safety device is a low water alarm that notifies the boiler operators the water level is below normal. The third is a low water cutout switch that when opened shuts off the burner. This switch is usually in the recycle limit circuit. So when this switch opens, the burner will shut down and no alarms go off, and the burner can be relit when the switch makes again. The fourth safety device to prevent dry boiler firing is a second low water cutout, usually called the auxiliary low water cutout switch, that trips the boiler and energizes the common alarm. Often the low water cutout and auxiliary low water cutout switches are different types of devices. One will often be a float switch, while the other is a capacitive probe and relay. Finally, preferred controllers include an input for a stack temperature thermometer. If the stack temperature goes over set point because there is no water in the boiler, the preferred controller trips the boiler, and this is a difficult device to disable. Boiler technicians have a fun job. It is their responsibility to prove everything on the boiler is designed per ASME and NFPA 85 boiler code and it's working properly. It doesn't matter if a mistake's made at the boiler factory, the burner factory, or something is installed wrong at the end user facility. It is the burner technician's responsibility to find these mistakes and make sure they're corrected. So when you design a boiler, it's important that the feed water system is designed to exceed the boiler water consumption and safety valve blow-off pressure. You need to call out the correct low water alarm, low water cutout, and auxiliary low water cutout switches and show them correctly on the wiring schematic. You need to correctly design and call out a high stack temperature alarm and shutdown. So additional technician responsibilities include making sure the stack temperature thermocouple and indication is working correctly. Make sure the stack temperature alarm and shutdown are enabled in the burner flame safeguard control. It's not practical to test the high stack temperature shutdown, and it's not required by code either, but you can make sure that it's working. So the next most common cause of boiler explosions is a hard light off. And NFPA has a very detailed procedure for how you light off a burner to prevent hard light offs. And I often see burner and control specifications that include all of these light off steps required by NFPA. It's not really necessary to call out these steps in your specification. All US-based burner and control suppliers have to follow NFPA. So this is the burner light off sequence, pretty much how it's detailed in NFPA 85. The first thing that happens is the recycle interlocks limits need to be made. And what's typically in your recycle interlocks circuit is a burner on off switch, an operating steam pressure switch, and sometimes the low water cutout. So you turn the burner switch to on. The next thing the flame safeguard does is the flame scanner proves that there is no flame in the furnace. It's important to make sure there is no flame in the furnace before you try and light it off. The flame safeguard system also checks to ensure the fuel valves are closed. There are proof of closure switches on the main fuel shutoff valves. And then at some point, the flame safeguard is going to do some self-diagnostics. And if it's a servo system, then the servos are going to be checked to make sure that the servo hasn't been replaced and that the limits of travel on the servo are currently the same as when they were set up. The next step is the flame safeguard system will drive the air damper to purge position. It's important to purge the boiler to make sure there aren't any combustibles in the boiler before we put a spark and more fire into it. So the flame safeguard will drive the air damper to purge position, and then it will prove the stack damper is open, and drive the FD fan VFD to purge position or purge speed if you have a VSD enabled on this boiler. Then we're going to prove we actually get to the purge position. This can be done by either a limit switch or by servo feedback. And then we're going to prove that all the non-recycle limits are made. These limits might include high gas pressure switch, low gas pressure switch, high steam pressure, auxiliary low water cutout, minimum air pressure switch, and maybe a high furnace pressure switch. These are all non-recycle limits that if you don't make all these limits, the light off sequence is going to shut down at this point, and the alarm's going to come on, and someone's going to have to reset the flame safeguard to try again. So once we've proven the purge position and all of our non-recycle limit switches are made, the purge timer is going to count down. And the purge time is determined by the technician. It's usually 4 to 10 air volume changes depending on the construction of the boiler. So after the purge timer counts down, the flame safeguard system is going to drive the air damper and the fuel flow control valves to their light off positions. Then it's going to prove the light off positions either with limit switches or servo feedback, and then it's going to energize the ignition transformer and the pilot shutoff valves. This should bring on a pilot flame, and the flame scanner proves the pilot flame is lit. So the next thing that's going to happen is we're going to de-energize the ignition transformer. This is done for two reasons. The first reason is to make sure we have a stable pilot without the spark being on. And the second reason is to make sure the flame scanner isn't seeing the spark itself. If it's possible to have just the spark on and no pilot flame, and sometimes a UV scanner can see that spark. So we don't want to energize the main fuel valves when we just have a spark. Well, we need to prove that a real pilot's there. And the way we do this is by de-energizing the ignition transformer and continuing to prove that the pilot is lit with the flame scanner. So if the flame scanner still sees the pilot flame after the ignition transformer goes off, then we energize the main fuel valves and open up the main either gas or oil. And then the flame safeguard is going to wait 10 seconds while flame is continuously proven, and then it's going to sort of turn control of either the jack shaft or the servos over to the fuel air ratio controller, and now we're in a state called release demodulate. And in release demodulate, the flame safeguard continues to monitor the recycle limits, the non-recycle limits, and the flame scanner input to make sure that as far as the flame safeguard system can tell, the boiler is running safely. So from a design perspective, we need to make sure the fuel train is designed per NFP 85, and that includes a double block and vent valve system. We need to select the correct low gas pressure and high gas pressure switches for the gas supply pressure. And then we need to correctly size the fuel flow control valve for the maximum minimum fuel input and supply pressure. Below is a link to a video that one of our technicians took showing one of our burners light off, and we might be able to embed that in the video. So additional technician responsibilities to prevent a hard light off. Inspect the fuel system to ensure it's piped correctly. Make sure the fuel system is piped per those diagrams in the back of NFPA 85 in the appendices. Verify the fuel supply pressure matches the burner drawings and the bills of material. Then know the opening direction of fuel, air, and atomizing servos. Oftentimes, flow control valves are not marked very well, and sometimes there's a particular valve manufacturer that cuts a mark in the top of the shaft that's parallel to the wafer in the wafer control valve, but then we usually put a servo coupling over that mark. So the only way to tell if the servo is open or closed, or if the valve is open or closed, is covered up by the servo coupling. So before you even try and light off, make sure you know which way is full open and which way is full closed on your fuel flow control valves and on your air damper. Um, if you can't tell by the way the valve is marked, uh, take the fuel train apart and verify for yourself. It's very important for technicians to know which way the fuel flow control valves especially are driving. Also, verify the stack damper is either fixed open or is driven open during purge. If you have draft control on a boiler, the stack damper position will be part of the purge position limit to make sure that the stack damper is actually open before you energize the fan. And then verify the air damper is moving to the purge position is going in the correct direction. And then an additional safety for technicians is when they're first lighting off a new burner, close the hand valve in the main gas drain the first time you light off. What this will do is you'll go through the light off sequence and you should be able to see a pilot flame, but when the flame safeguard energizes the main fuel valves, uh, you're not going to get any gas or oil, and eventually you're going to flame out. So this just tests the flame scanner to make sure that that it's really seeing flame and you're not getting any kind of a false flame. And while you have the pilot lit, you can verify your low fire air by examining the pilot flame. An all blue or blue and straw colored flame indicates adequate air for light off. A really long, dusty orange flame indicates you probably don't have enough air for low fire, and your air damper position or your VSD should be bumped up at low fire. And then, as I mentioned before, let the burner trip once on MTFI flame failure. That proves your flame scanner is working correctly. There's a lot more responsibilities for the technician the first time they light off a burner, and this isn't something the operators are going to see. It's mainly for the burner technicians, but I wanted to include this so that everybody can get a taste of what the burner technicians go through the first time they light off a burner. And oftentimes, especially in fire tubes, this is done during fire test at the fire tube burner boiler factory. So an end user probably wouldn't even see this, but it's an essential step that always gets done. So when we're first lighting off a burner on either gas or oil, we want to set the fuel valve servo position deliberately too low because we really don't know how much flow we're going to get through the valve at different opening percentages. So if we're going to air, we want to air on the low fuel side. So deliberately set the valve servo position deliberately too low. Watch the burner from the back as you attempt to light off the main flame. Ensure the pilot lights off, and if there's no main flame the first time you light off, try again once before adjusting the gas flow control valve. Sometimes you have to fill up the gas manifold with gas before it's going to light off. If there's still no main flame, gradually adjust the gas flow control servo position up a little bit, no more than 1 or 2 degrees, and try again. And this may take a while as you slowly open up the fuel flow control valve to get to a safe light off position. So we want to design the fuel and atomizing trains for NFPA 85 guidelines, and these are special considerations for oil firing. Um, in some ways, oil firing is safer than gas firing, but in other ways, it can be more dangerous, especially with that first initial lighting off of the burner that's done by a burner technician. So the oil flow control valve has to be sized for the correct high fire heat input and supply pressure. And the low oil pressure switch, high oil pressure switch, low atomizing steam pressure switch, and low atomizing flow switches all need to be wired correctly into the flame safeguard, and all of these will go into the non-recycle limit circuit. You want to minimize the piping length between the last shutoff valve and the burner. This is a operational thing, and it's also will make the burner safer to operate. So if you're steam atomized, the first time you light off, you want to bleed some steam into the boiler during purge to remove any water from the atomizing line and make sure you have dry steam. If the boiler is oil fired only, repeat the gas steps above to ensure a good pilot and adequate low fire airflow. Set the oil flow control valve light off position deliberately too low. Oil flow control valves can be very sensitive to low fire, even more so than gas flow control valves. And then when lighting off oil, watch the oil gun from the back of the furnace. Look for sparkles that indicate oil is being ejected from the gun. If you don't see any oil or just a couple of sparkles, try again without adjusting the oil flow control valve, because the oil gun has to be filled up with oil before you're going to get any oil at the nozzle or at the tip where the oil burns. So the first time you try and light off, you might just be just filling up the oil gun. If you don't see oil spray after a second light off attempt, increase the oil flow control valve setting no more than about 2 degrees and try again. And just like gas, keep repeating this procedure, but watch the oil gun every time you light off until you get a lean, stable oil fire. So sometimes the pilot flame doesn't light the oil spray. So we've got to keep an eye out for that. So watch for oil spray during light off attempts. Watch for oil accumulation in the furnace. The only way you can tell how much oil is in the furnace before it lights off is by watching the oil gun as you attempt to light off. If you see a bunch of spray that's not being lit off, that's oil accumulating in the furnace, and you don't want that to happen. Um, if you have some oil in the furnace you think that didn't light off for one reason or another, it's okay to take an extra purge if you need to. You know, reset the burner, let it go through purge, and then as it's going to low fire and getting ready to light the igniter, turn the burner off and turn it back on again, and that'll get you a second purge. If you see oil burning on the bottom of the furnace, purge until the flame goes out and then purge again. And if you think you have oil in the furnace floor, if you have gas on the burner, you can switch back to gas to burn all this oil off and then safely try oil again. Once the oil gun is lit, look for drips and dribbles of oil that can accumulate in the furnace. The tip of the oil gun should be over the refractory throat so that any oil that's dribbled by the gun is vaporized away. The danger is dribbling oil can run backwards through a burner and accumulate in the windbox and cause a windbox fire. So the first time the burner is lit off, we always want to make sure we don't see any of these drips of oil. It's possible that there's a leak in the oil gun, something's not tight, and that oil is going to drip out the gun and then drip out the carrier tube and potentially back into the windbox. Okay, so as I mentioned in the beginning, most of those steps are burner technician steps that they go through the first time a burner is lit off. Um, Once the technician is finished, he's going to find the happy place for the gas flow control valve, the oil flow control valve, the air damper, and the FD fan VFD, if there is one, that's going to provide a safe light off every time. And those positions get locked into the flame safeguard controller so that the burner always lights off at the same safe positions every time. So the last major way that a boiler explosion can happen is just fuel side rich combustion. This is when the burner's already lit off, been lit off, and then for one reason or another, the boiler goes rich and can cause an explosion. So these are the things that need to be done to prevent fuel side rich combustion. Um, Whether it's a jackshaft system or a parallel positioning system, all the devices have to be tightened down or drilled and pinned to prevent something sliding and getting our fuel valves or our air damper out of position. And that used to be the only way we could really make sure that our combustion was always on curve. When we had a jackshaft system, you sort of mechanically linked the fuel valve to the air damper. And that's why it was called a linkage system. With a parallel positioning system, we have feedback on the servos, so we sort of electrically link the fuel and air valves together to make sure they're always in the same position. But this is an area where technology in recent years has really made boiler firing safer. Um, Oxygen trim systems have been around since I entered this industry in 1990, but it seems like for the first 15 or 20 years of my career, they were sort of a joke. And most times when you saw an oxygen trim system in the field, it was disconnected because it didn't work well. The technology's come a long way now, and oxygen trim is very reliable, and the oxygen analyzers are much more reliable and longer lasting than they used to be. So oxygen trim corrects for changes in ambient temperature and other minor fuel air ratio changes to make sure that you are always at your oxygen trim set point, regardless of firing rate. And then oxygen trim is often sold as a fuel saving technology, but the oxygen analyzer is also a safety device. Jackshaft boilers and parallel positioning systems have components that can break or slip. If something changes and stack oxygen went too low, a boiler controller with oxygen trim will shut down the burner and sound the alarm. Finally, an opacity monitor will tell you if a boiler is smoking. Oil-fired boilers will smoke if they are run even a little rich. Gas burners will smoke too, but usually the stack oxygen needs to be close to zero before natural gas will smoke. But in either case, an opacity monitor like the preferred JC30 will detect the boiler smoking and sound an alarm or trip the burner. New York City is the only jurisdiction to require opacity monitors, but they're an important safety device that should be considered for any boiler. So technician responsibilities for preventing rich combustion. When they're tuning the burner, um, they have the fuel flow control valve and air damper and VSD in manual. So they've got total control over fuel and air. And during this time, air should always lead fuel when increasing firing rate. So they'll bump up the air first, intentionally go very lean, and then bring the fuel up to follow and slowly increase the fuel until they get to the oxygen or the stack oxygen that they want. It's important to take baby steps, especially at low fire. Uh, Fuel flow control valves and air dampers can be very fast opening at low fire. If they're tuning from top down, meaning tuning from high fire down to low fire, they kind of want to do the opposite and decrease fuel in each step before decreasing air. And all this time, they need to be watching the stack oxygen and carbon monoxide. Those two indications will tell you if you're burning too rich. And then finally, they need to frequently check the flame. Um, you can't just rely on your combustion analyzer to tell you everything that's going on inside the furnace. Especially oil firing. Oil firing will tell you if it's too rich or too lean just by looking in the back of the furnace. And when you make a change to your fuel air ratio control, you'll see it immediately in the flame. It takes a few seconds for that new oxygen and new CO to settle out on your analyzer. So the quickest source of information you have is actually visually looking at the flame. And then this is good advice for technicians and also boiler operators: is know what your normal flame looks like. Know what the normal safe flame looks like when the burner technician came out and tuned the burner. And if you're firing oil, you need to know what under-atomization and over-atomization look like. Um, they look similar to a boiler running too rich or too lean, but not quite. And then if for the technician, if CO gets too high, you want to decrease fuel, do not increase air. You can have all the conditions for a puff in the boiler if you're running too rich. You can have, carbon monoxide is combustible. If you have carbon monoxide, you could also have other unburned hydrocarbons that are combustible. You've got flame in the furnace, you've got hot refractory. The only thing that's lacking is air. So you don't want to give the furnace more air under those conditions. You want to give it less fuel. And if CO gets completely out of control, the technician can always shut down the burner and try again. And they can take an extra purge if they want. It's not super uncommon for the CO to get out of control when you're burning too rich if you add a couple of degrees of fuel and get way more fuel than you expected. And then additional safety considerations for burner technicians. Get the feed water system working before you tune or before you do the fuel air ratio control. That way there's just one less thing for you to worry about if the feed water system is working well and automatic. And then you want to try to tune the boiler at a time when the plant has some load for you. Boilers are often oversized, so it can be difficult to get enough load to go to high fire for any length of time. Technicians should get an operator to control the firing rate on other boilers to give you some load, or maybe shut down other boilers to give the burner you're firing some load. And if you have a steam vent and need to vent steam, get an operator to do it. Setting the fuel air ratio control in a burner is demanding enough. The technician doesn't need to have to worry about the steam pressure as well. And then finally, we tell our technicians to silence or ignore your phone when you're firing a boiler. Firing a boiler is much more important than taking a phone call, even if it's from your boss. Also, when the technician is done, he needs to drill and pin all the servo couplings. Jack shaft systems were known to slip from time to time, so the drive levers and everything were required to be drilled and pinned when the technician was done. But servo systems have servo mounting brackets and servo couplings that can slip. So those need to be tightened down and then drilled and pinned once the technician is done setting up the burner. Also, before the technician is completely done, they need to find a plant person in charge and demonstrate all the boiler safeties. The plant people need to see where these boiler safeties are, how they work, and that they were all tested. And we have a form, we have the plant person sign off that he's witnessed that all these boiler safeties are operating correctly. And then we encourage our technicians to just watch the boiler run for a while under different loads and make sure that all the PID loops are tuned correctly and that the boiler is going to operate without any problems. The mark of a really good boiler technician is one that doesn't get any callbacks. They've done such a good job setting up the burner, watching it run, that the boiler can just run for the next, several months without any issues that require him to go back. Okay, so thank you for sticking around to the end. We packed a lot of information into one webinar. If you want to learn more about any of the topics covered today, I recommend you pick up one of the books I mentioned earlier. And if you have a project that might involve preferred burners or controls, please reach out to me or one of the other sales engineers at Preferred. We're going to take questions now. You can submit your questions via my email address or in the chat box on your screen. I'm David Oaf with Preferred Utilities. I'm joined by Rob Frohawk. He's the engineering manager at Preferred Utilities. And I asked him to be on this webinar about boiler safety because Rob is on the NFPA 85 steering committee that really sets all the rules in the boiler industry that the rest of us have to follow. Rob, how you doing today?
Doing great. Hey, that was I liked your video. That was good stuff.
Okay, we had some questions and we'll work through those. If anybody has additional questions, you can put them in the chat, or you can, that's probably the best way, or you can email them to me. The first question we had is, how often should I check the safety limit devices? Rob, since I build you up as to be the expert, do you want to take this?
Sure. So the safety limit devices cover, like, and we saw in the video, covers a lot of different devices. Certainly the pressure switches on the steam side and the fuel side, I would say at least once a year. Most people do, major service on the boiler at least once a year, and that's a good time to do it. Certainly any time that you're bringing a fuel back onto service that may have been down for a while, that's a good time to test your fuel limits. So at least once a year. It also includes even the mechanical devices like the relief valves have a service schedule associated with that, and that's pretty much something that you can't do yourself. An ASME valve on the steam side will have to get sent out and get to be recertified.
So I'll add to that the scanners. UV scanners most often fail showing flame. We call that a runaway scanner, and it's a very dangerous condition. And NFPA 85 says that if the burner doesn't cycle at least once every 24 hours, you should use a self-checking scanner. And I think, with small boilers, that's advice that's universally ignored. I think very few small fire tube boilers have self-checking scanners, and not all of them cycle every 24 hours. Doesn't one of our new controllers have a function you can enable that'll intentionally shut the burner down every 24 hours at a time that you set to check the scanner?
I believe the BurnerMate Universal has that option on it. Yeah, it's like David said, that's a definitely something that people don't realize is in the code. And you can, if you're not sure if you have a self-checking UV scanner, self-checking UV scanners are usually, let's call them larger in diameter, because they have the way they check themselves is they literally put a inside, they put a flapper in front, and the electronics in the flame safeguard make sure that the flame signal goes off, and then when they lift it up again, it comes back on. So that's what we mean by a self-checking scanner. Some manufacturers will call their amplifier a checking amplifier, and that's not really the same thing. You want a self-checking scanner, and that applies to ultraviolet scanners.
So it doesn't apply to lead sulfide IR scanners that typically fail showing no flame. And then some of the newer UV scanners are solid state, and they will typically fail showing no flame. So more of a fail-safe operation.
That's
Okay,
right.
moving on to the next question in the chat. Oh, how often should I check my flame scanners and how long do they last? Okay, so we already covered the first part of that question. The second part of that question depends upon how badly you abuse your flame scanners. In the single burner package boiler industry where we don't have preheated air, the scanners are going to last several years as long as you don't get moisture to them. I came from the utility market where I worked for a few years where we had preheated combustion air, and our wind boxes were 500 and 550 degrees or so. And in that environment, it seems like utility boilers would lose about a quarter of their scanners every summer just because they got cooked. Several of the manufacturers came up with scanner cooling air boots to kind of bathe the scanner in cool air and make them last longer. But single burner boiler scanners should last several years, I would say.
Yeah, and in terms of checking scanners in the boilers that we're talking about, there are several burner management systems that allow for 2 scanners, and the majority of those are set up that as long as either scanner sees a flame, you can continue to run. That greatly assists in being able to test the scanners without having to bring the boilers down. Also, in terms of scanner health, nowadays, with needing lower emissions, more and more burners are using flue gas recirculation. and that will always bring in more moisture into the wind box. And now we're seeing more when we have that moisture. It can condense on the scanner and cause scanner not only trouble with seeing the flame, but again, that will give you trouble with um, with sort of false trips, if you will. So in those scenarios, we've seen more and more people providing dry, what we call purge air or seal air, that we can introduce in front of the scanner and keep that lens dry, keep the moisture down, and increase uptime.
Okay, you don't see scanner cooling air very often in the fire tube industry or the single, package boiler water tube industry, but it is one of the tricks that you can use to keep your scanners cleaner and cooler. And virtually everybody's scanner includes a little 1/8 or 1/4 inch MPT fitting for cooling air, or sometimes the cooling air fitting is built right into the swivel mount for the scanner. Okay, do the boiler relief valves need service? They do, and the schedule really depends on the pressure of the boiler. Boilers that are run under 400 psi, typically they're manually tested once a month and pop tested once a year. That's a rule of thumb. Some customers have different requirements. The Veterans Administration has different requirements, and sometimes the authority having jurisdiction has different requirements for how often you test the safety valves. And a lot of places recommend that you have them tested and refurbished once a year. When you do an annual inspection on the boiler, um, you can send out the safety valves to be refurbished. And a lot of plants will have 2 sets of safety valves for each boiler. One is always out being refurbished while you run on your other set, and then when you take an annual outage, you swap your safety relief valves. Okay, notes about our audio problems. Lots of notes about it. Okay, here we go. Okay, what are the best indications that the purge system is effectively working? NFPA kind of dictates this. So, Rob, can you answer this for us?
Um, sure. So basically, purge is proven in one of 2 ways, and you're trying to both ways are making sure that you're getting air through the boiler, like we saw in the video, that depending on if you have a fire tube or a water tube will dictate how many air changes, if you will, that you need to prove, and that should be set up from the beginning as to how long. So the 2 methods of proving purge, one of them is if your airflow switch is proving actual flow, meaning like a differential pressure across something in the air path, and then there's no way of shutting that off downstream, just like any sort of differential pressure flow device. You're proving flow, and you're just trying to reach something that is 80%, is at least 80% of the maximum airflow while the boiler is running, is what you're looking for. The other method of that, if you can't do a differential pressure, is where you can measure static pressure of the discharge on the fan, but you also need to prove all of your devices are in the open position. So and really, you want to make sure that when the boiler is down and you're, for maintenance, that these switches are not just stuck in the proven position. With lifting the wires off of the switch, actuate the damper and make sure that the switch is open when the valve is not in the purging position, and then the switch closes when you get there. And you can have, depending on the type of system you have, you can have a damper on the inlet to the blower. You can have, some even have an additional damper on the outlet of the blower. And if you have a stack damper, there will be a switch up there as well. So making sure that all those switches are not just, you know, dare I say jumped, but at least stuck in the proven position is what you'd want to check during a maintenance situation.
So Rob, 3 times in my career, I've seen stack dampers slam shut because they weren't welded open correctly. And
Mm,
it happened on a water tube boiler that the stack damper was held open by baling wire.
yeah.
And it happened to me on a, probably shouldn't mention them because they're still in business. It happened to me once on a Kiwani boiler. I could pick on them because they're out of business. And before Kiwani went out of business, they cheapened their boilers up so much that they had like a 1/2 inch shaft with bearings on either side of the stack holding the stack damper, and they had a little like 5/16 inch set screw that would just tighten into that shaft, and that's supposed to hold the damper open even for a 1200 horsepower boiler. So after it happened to me once, I was paying attention, so I noticed right away. I was able to shut the burner down, and nothing was damaged. But every time after that, I started up a Kiwani boiler, I would always make a sketch and have the contractor, weld uh, a an assembly onto the stack damper so it could be tightened down and isn't going to slip and move, because most times when that stack damper closes while you're firing, it's going to be bad news and it's going to do some damage to the boiler.
Yeah. Certainly if you have a draft control system, you're always going to have a furnace pressure switch that should, um, you know, if something slips or if the damper's closed, that switch will shut down, the BMS. Some people think that if the damper is manual and they climb up on top of the burner and take that manual switch, or sorry, that manual damper, and you know think that it's locked open, that if that damper is manual, that they don't need a furnace pressure switch. I always appreciate a furnace pressure switch, because just in case somebody forgets, the pressure goes high inside of the furnace. You really don't want to run for very long in that condition.
Yeah, and furnace pressure switches aren't an expensive device, and even on boilers that don't have draft control, I've seen the method of securing the stack damper open slip. So
Yep, absolutely.
safe insurance. So next question's a good one. How many hours or days would it take to perform a complete commissioning testing of all boiler systems for safe long-term operation? This is something our service techs do, virtually every day. And when they go out to do a PM on a boiler, they're going to run the boiler and retune it from low fire to high fire on all the fuels, and then they're going to check all the safety limits and manually trip the boiler on all the safety limits on the boiler. And if the plant has load and nothing really goes wrong, they should be able to do gas and number 2 oil both in the same day. It can take longer if the boiler doesn't have any load. It can take a long time to get to high fire points, because you trip on high steam pressure or you trip on high water temperature, and then you've got to wait for the pressure to come down before you can light off again. Then you end up taking a quick stab at high fire. But if there's load, you should be able to do 2 fuels in one day. And we like to have the plant witness that us tripping the boiler on all the limit switch devices so that they know that it works. And back in the day, before oxygen trim, they used to recommend that you get this done once in the spring and once in the fall, so that your boiler can be retuned for low ambient temperatures and high ambient temperatures. And now that we have oxygen trim, the oxygen trim will compensate for lower and higher ambient air temperatures, but it's still important to do all the safety checks on the boiler and make sure all the safeties are still working, and at least check combustion, high fire to low fire, and make sure that everything is still the same. And I'd like to add, there's a really good reference for testing boiler limits, and that's the VA guide. Um, Rob, do you remember the full name? It's the VHA Safety Testing Guide to something or other, 5th edition.
Yeah, it's the uh, it's called the
It's a very
VHA.
long name, and I can never remember the whole name. And they're on the 5th edition now.
It's called the VHA Boiler and Associated Plant Safety Testing Manual, 5th edition.
Okay, I wasn't even close except for the 5th edition part. But that manual provides step-by-step instructions for how to test all the limit devices on a boiler, and it has very good diagrams in it. And the VA hospital system really does a good job. Their safety requirements for their boilers are above and beyond NFPA 85 in a couple of instances. And the VA hospital system places a lot of emphasis on the testability of these limits because, in my experience, a lot of times what happens when there's an accident on a boiler is they find out that one of the limit devices was bad, and the testing procedure for determining if it was working wasn't done in such a way that it found the failure in the device. And I'll give you a for instance for that. Most boiler operators are told to blow down each of the water columns every day, to make sure that your low water cutouts are working. And what can happen with float switches, I was going to name the manufacturer, but I better not. And it's not their fault. What can happen with float switches is the float can get stuck, and when you open up the blowdown valve, you're putting no pressure on one side of that float and steam pressure on the other side of that float. So if the float was stuck, you're more than likely going to unstick it. So what the VA requires is, and I think they call it an evaporation test, is just close the feed water line to the boiler and let the boiler naturally run out of water slowly as the water gets converted into steam, and that will detect a stuck float without unsticking it during the testing process.
Right.
So
Yeah.
it takes time, but and you eventually trip the boiler. So you got to make sure you have another boiler on to carry the load, but much safer way of doing the testing. Okay, so next question. Um, can you talk about what could happen if the airflow switch is jumped out?
So, um, depending on the controller that you have, some controllers will allow the airflow switch to be jumped, which is obviously not what you want. There are some controllers that will monitor that input and make sure that that switch opens up when the blower is off, and as an enhanced method of safety. Even without those, you should definitely be checking again by lifting the wire, using an ohm meter, and running the fan, and making sure that that your minimum airflow switch is opening up when the fan is not running. Um, there are many switches out there that if you back the screw all the way out, it will be made all the time. And really the only way you're going to see that is, again, testing it with an ohm meter.
And the minimum airflow switch probably gives you more nuisance trips than any other switch. So it is a device that sometimes operators will just back out to keep from having nuisance trips. And
Exactly.
and you know, it's you also have the feedback from the motor starter to know when the fan is running. But I saw a plant one time that this plant was on my way home from work, so they would call me a lot, and then I would stop by, and they were smoking one day, and I found that they had sucked a big plastic bag into the fan inlet.
Mhm.
It was like an 800,000 horsepower fire tube boiler. So there's a screen over the fan inlet, and then kind of a shroud because we were inducing FGR, so you couldn't see the this bag. I think it was like a bag for boiler chemicals or something. Got this empty bag had gotten sucked into the screen and was choking off most of the airflow to the burner and was causing them to smoke. But you know, the airflow switch should have stopped that as well. It should have detected when there wasn't enough air. And this has gotten more difficult now with variable speed drives because the way we used to check a minimum airflow switch when, we just had across the line starters for our FD fans was you you disable the fan, you shut off the fan, and the minimum airflow switch should close or should open, sorry, within 4 seconds. And you keep adjusting until it opens within 4 seconds. Now with VFDs, 4 seconds at high fire could mean that at lower flow rates, the air switch just doesn't make. So again, the VA addressed this by just mandating that their VFDs not get turned down below 40 hertz. And that way you can still have a realistic setting on your airflow switch. So just because we prove the fan is running doesn't necessarily mean that we have adequate airflow through the furnace. But most systems that have FD fan VFDs also have O2 trim. So like I mentioned in the webinar, O2 trim is also a safety device. It's an energy saver or fuel saver, but it's also a safety device. And that that kind of got hit home with me by our representative in Puerto Rico. It's always 85 degrees and beautiful in Puerto Rico, and yet they still recommend O2 analyzers on all their boilers because it's a safety device, and they're burning mostly oil down there, so O2 trim can keep you from smoking when you're firing oil.
Absolutely.
If firing biofuels, do they shorten the scanner life? We fire a ton of biofuels, and I haven't seen this. How about you, Rob?
Nah, neither have I. Um, you know, again, kind of like what I said before with if you have anything that is any sort of oil that that could produce, particularly like heavy oil, that as long as you have some sort of purge air or seal air going down to the scanner should work just as long. But I don't think there's anything particular to biofuels that are aggressive toward a scanner.
Yeah, the scanner glass is going to be impervious to anything in biodiesel or anything else. Um, I will relate one issue I had sort of with biofuel. Way back in the 90s, we provided a fire tube boiler that was getting all of its combustion air from a building where they were boiling chicken. It was a plant in California, and if you've ever boiled chicken without any spices, it's a horrible smell. So they wanted to do this for odor remediation, and we pulled all of our combustion air from this building where they were boiling chicken, and the inside of the burner and the scanner were getting lined with a white oily powder, and it would build up on the scanner, and we would eventually trip. And we tried putting purge air to it, and that didn't really help much. So we kind of redesigned the scanner mount so that it was easy to get to for the operators to clean every once in a while. But that's my only experience with that, and that's not really even firing biofuels. So I don't know if that's applicable. Sorry.
Right. Let's see.
Okay, so the next question is it a safety requirement in all the states also to have the feed water pump maximum pressure higher than the boiler safety valve setting value? In this way, the pump can fill the boiler with the safety valve open. Isn't that an NFP85 thing, Rob?
I don't know if it's actually specified in NFPA 85. I'm pretty sure it's an ASME, but
Okay,
definitely like we
that is
showed
a
in the
requirement though.
video that yeah, absolutely. If you think about it, that um, you know, the relief valves are based on the heat input to the boiler, and then your feed water system should be related to how your relief valves are set. So if everything was working fine and you were firing at 100% out of control, and your relief valves are opening, steaming away so you don't overpressurize the boiler, and your feed water valve is putting in more water than you're relieving in your relief valves. That's how everything is supposed to be sized.
Right. And I think when you do the blow off test, they want to see the pressure accumulate in the boiler no more than I think 6 or 8% above the pop off pressure of the safety valve. So your feed water pumps have to be sized for at least that pressure. So
Yeah, and to get to get any sort of feed water control, you want to make sure that the pressure going into the feed water valve, you know, if you have a 100 psi boiler, you'd want at least 120 psi going into into that valve, so you have some controllability. If you only had, if your differential across the feed water valve is only 3-4 pounds, you're not going to get really good feed water control anyway.
yeah. So that's it. We're over an hour. So attendees qualify for an hour of PDH credits. Um, in the past, we've had questions that have stumped me and the other presenters, but having Rob on the line, we didn't get stumped by any of the questions today. So we didn't have to give away any free preferred swag. So I consider that a small victory. Rob, thanks again for doing this.
My
Our
pleasure.